Dear viewers, the topic of this lecture is calculation of volume of a 3D solid of revolution by the method of washers. And as we know, a solid of revolution is a solid that is created by revolving a plane region about a line. So let me first distinguish between method of disk and method of washers. If you revolve this plane region about x-axis, then you will get a solid material like this without any empty interior. However, if you revolve this plane region about x-axis, then you will get a solid material like this with this empty interior. And again, if you revolve this region about y-axis, then you will get a solid material like this. You will get a solid material like this. And if you again revolve this region about y-axis, then you will get a solid material like this with empty interior. This part is empty. So in order to calculate volume of these types of solid material without empty interior, we will use disks method of disks. And in order to calculate volume of these types of solid material with empty interior, we will use method of washers. Method of washers. But the question is, how can we do that? If you revolve about x-axis, then the cross section will perpendicular to the x-axis, and if you revolve your cross section, if you revolve a plane region about y-axis, then your cross section will perpendicular to the y-axis. And disk method was something like this. The area of your cross section, which is function of x, and you need to integrate area of the cross section from one end to another, and volume for this one, y equal to, let's say y equal to c here, and here y equal to d. So y equal to c to y equal to d, a y dy. And since the disk is circular, so the area of this cross section will be pi r square, and r is nothing but fx at x. So it was like pi fx square, and this one was like pi fy square. But in order to calculate volume in case of washers method, you need to subtract this region, the volume of this region. So the formula will be pi fx square minus, this is the fx, this is fx, and you need to subtract gx from fx. So pi fx square minus pi gx square, and integrating from one end a to the other, a to b. And for this one, your formula will be b equal, since you are revolving with respect to y, so your cross section will perpendicular to the y-axis, and in that case your formula will be y equal to c to y equal to d pi fy square, because this radius is fy. You see, x equal to fy, and this radius is x equal to gy. So pi fy square minus pi gy square dy. So let me review again. If your cross section is, if you revolve a plane region about x-axis, then your cross section will perpendicular to the x-axis, and your formula will be this one, and your volume formula will be this one when you revolve a plane region about y-axis, and in that case your cross section will be perpendicular to the y-axis. So your volume formula for the method of washers will be this one. So let me say it again. Now we have two volume formula. If you revolve a plane region about x-axis, then your cross section will perpendicular to the x-axis, and in that case your formula will be the first one, integrating with respect to x. And if you revolve your plane region about y-axis, and your cross section in that case will be perpendicular to the y-axis, so your formula will be the second one, integrating with respect to y. So let's try to solve some problems in order to calculate volume by the method of washers. And let's try to solve these examples. Example 1 to 6. Find the volume of the solid generated when the region enclosed by the following curves, that is revolved about x-axis. So if you revolve about x-axis, then our formula will be the first one. So let us try to use this formula in order to solve these problems. So the first one is fx equal half plus x square and gx equal x over the interval 0 to 2. First one, let me first draw the graph. So the first one, fx equal x square plus half. We know y equal to x square is a parabola which is open up, vertex at the origin. But here vertex will be at here, a half distance away from the origin, and the other line gx equal to x. So other line will be a straight line which is this, and this one, the parabola, will be something like this. So this is a rough sketch, and the interval 0 to 2. So 0, 1, 2 is here, and so our region is this one. This curve y equal to x, and this one y equal half plus x square. Now if you revolve this region about x-axis, then you will get a 3D solid which will look like this. With empty interior, but the water will not fall down if you put water here. You can keep water inside this solid material. Okay, so we want to calculate volume of this solid material. So let us try to take a cross section here which will something like this. This is a cross section, and fx will be this one, since this is our x-axis, and gx will be this distance will be gx. So let us try to use volume formula 1, which is x equal a to x equal b pi, let me put pi out of integration sign, fx square minus gx square dx. So here x start at 0 and end at 2. and the curve above 1 is fx, which is half plus x square minus the curve below 1 is y equal to x, so gx square dx. Now you can easily integrate it, 0 to 2. Let me first simplify. 1 by 4 plus x square plus x to the power 4 minus x square dx, and x square will cancel by 1 by 4 x plus x to the power 5 by 5, 0 to 2. So first, if you put the upper limit, you will get 2 by 4, it means 1/2 plus 32 by 5, and if you put lower limit, it will be 0. So this equal by the LCM 10, 5 plus 64. So this equal 69 pi by 10. This is the answer. This is the volume of this solid material. So now let's try to understand example 2. Here we have two curves, y equal to minus x square plus 2 and y equal to x and y axis. So we have three curves. The first one is y equal minus x square plus 2. So this one will look like this. Y equal to minus x square is a parabola which is open down, hence we need to add 2, and other one y equal to x and the other one y axis. So this is the reason enclosed between three curves, y equal to x, y equal to minus x square. Now if you revolve this region about x axis, then what will be the volume of that solid? So in that case you need to take a cross section about which will perpendicular to the x axis. So at this point what is fx, and at this point what is fx or gx? You need to subtract the lower one from the upper one. So volume will be pi, and x equal, x start at here, x equal 0 and end at here. So what is the coordinate of this point? In order to find the cross section of these two lines, let me equate these two equations. So 2 minus x square equal x, therefore 2 minus x square minus x equal 0. This implies x square minus plus x minus 2 equals 0. This implies x square minus 2x or plus 2x minus x minus 2 equals 0. So x equal to 1 and negative 2, and we need this one. So when x equal to 1, y equal also 1 from here. So 1 1 is the point of intersection. So the lower limit will be 0 and upper limit of x will be 1, and The curve above 1 is this one. At this point, y equal to 2 minus x square. So 2 minus x square whole square fx square minus gx square. Gx equal to x dx. This equal pi. If you square it, you will get 4 minus 4x square plus x to the power 4 minus x square 0 to 1 dx. This equal pi 0 to 1 x4 minus 5x square plus 4 dx. So this equal x to the power 5 by 5 minus 5x3 by 3 plus 4x 0 to 1. This equal 1 by 5 minus 5 by 3 plus 4. So let me write it here. Pi into LCM 15. So 3 minus 25 plus 60, and this equal pi times 15, 63 minus 25, which is equal 38 pi by 15. So this is the answer. So now let's try to solve example 3. Here we have two curves, y equal to x squared and y equal to x cubed. So let me first sketch the graph. And one curve, and here you need to note that two of them intersect each other at 0, 0 and 1, 1, let's say here, and y equal to x square is a parabola which is open up, something like this, and y equal to x cube is a bit, it will be something like this. Okay, so both of them, this is our region, both of them intersect each other at 1, 1. The above one is y equal to x square and the below one is y equal to x cubed. So here if you revolve this region about x-axis, then you will get a solid material, something like this. So now let us take a cross section here. And this cross section is perpendicular to the x-axis. So our volume formula will be this one, and the x start at 0 and end at 1. So the lower limit and upper limit 0 and 1. Fx is the above one, x square. So this is our formula, fx square minus gx square dx. So here fx means the above one, x square, and gx means the lower one, x cubed whole squared dx. So this equal pi x to the power 4 minus x to the power 6 0 to 1 dx. This equal x to the power 5 by 5 minus x to the power 7 by 7 pi 0 to 1, which is equal 1 by 5 minus 1 by 7. This equal 7 minus 5 by 35 into pi. So the answer will be 2 pi by 35. Now let's try to solve example 4. Here we have also two curves, y equal to root x 25 minus x square and y equal to 3. and we need to revolve it about x-axis. So first let us sketch the graph, x-axis and y-axis. So we know it's an equation of a circle, this one. If you square on both sides, you will get y square equal 25 minus x square. It means x square plus y square equal to 25. So it's a circle having radius 5. So let's say 5 is here. So this is a semicircular region, and another curve y equal to 3. So y equal to 3, let's say here, this is y equal to 3. And what is the coordinate of this point and this point? You need to calculate. If you put y equal to 3 here, then we have 3 equal root 25 minus x square. 25 minus x square equal to 9, squaring on both sides. So x square equal 16, therefore x equal plus minus 4. So this one is 4, 3, and this one minus 4, 3. And this is our region. Enclosed between two curves is this region. Now if you revolve this region about x-axis, you will get a solid material with empty interior. So we need to use method of washers, and this is our formula. So x start at minus 4 and end at 4, and the curve above 1, if you take a cross section here, then the curve above 1 is y equal root 25 minus x square, and below 1 y equal to 3. So root 25 minus x square whole square minus 3 square dx, and you can cancel this pi. You can multiply it by 2 and write 0 to 4 because the region is symmetric to the y-axis. So 25 minus x square minus 9 dx, which is equal to pi 0 to 4, 16 minus x square dx, and the integration will be 16x minus x cubed by 3, 0 to 4. If you put upper limit, you will get 64 minus 64 by 3. So the answer will be 256 pi by 3. So now let's try to solve example 5. Here we have also two graphs. So it means we have two equations. The first one is y equal x square, and the second one is y equal 4x. So let us sketch the graph first. And y equal to x square is a parabola which is open up, and y equal to 4x is a line which will be something like this. And the question is, what is the point of intersection of this point? What is the coordinate of this point? So to know that, you can equate these two equations. So you can write 4x square equal to 4x, x square minus 4x equals 0, x minus 4 equals 0, so x equals 0 and 4. When x equal to 4, y equals 16. So this point is 0, 4, 16. So the volume will be pi 0 to 4, x lower limit of x 0, upper limit 4, and the curve above 1 is this one, which is y equal to 4x, and below 1 is this one, which is y equal to x square. So 4x whole square minus x square whole square dx, and this equal pi 0 to 4 16 x square minus x to the power 4 dx. And let me skip this calculation, you can do it by yourself, and the final answer will be 2048 pi by 15. So you can try in your apartment to get this result. And now let us solve example 6, and it says here we have again two graph, y equal to sin x and y equal to cos x. So it's a trigonometric function, and we can easily sketch y equal to cos x, and we know the range of cos x is 1. So this is the cos x, this graph y equal to cosine of x. And how about 5 by 4 is here, sine curve, and sine curve will be maximum at 5 by 4. So sine curve will be like this. So at 5 by 4, this is our region. Here x equal to 0 and here x equal 5 by 4. So if you revolve this region about x-axis, then the volume will be, you will have an empty interior. So your method will be the Wasser's method. So the formula will be that if you take a cross section like this, since if you revolve about x-axis, the cross section will be perpendicular to the x-axis. So this is your cross section, and at this point x equal what? X equal, this is our cos x, y equal cos x. So at this point y equal cosine of x whole square minus, at this point y equal sine of x. So sine of x whole square dx, and the lower limit of x 0, upper limit 5 by 4, and this equal pi 0 to pi by 4. We know cosine square x minus sine square x equal cos 2x, and integration of cos 2x is sine 2x by 2, 0 to pi by 4 pi, which is equal pi into, if you put sine pi by 4 here, then sine pi by 2 equal 1 minus 0. So this equal pi by 2.